Have you ever looked up at the night sky and felt a sense of profound wonder? The stars, scattered like diamonds on black velvet, seem so distant, so impossibly far away. We see a universe that appears smooth, vast, and mostly empty. It looks like a great dark ocean, calm and predictable in its grand cosmic dance. But what if that smoothness is just an illusion? What if beneath the surface of everything we can see, there lies a hidden reality? A reality that is chaotic, dynamic, and filled with secrets we are only just beginning to imagine. This is a story about the very fabric of space and time itself, and the possibility that it holds tunnels to other places, and perhaps even other times. Imagine the universe not as a smooth sheet of paper, but as something far more intricate and complex. What if, at the smallest scales imaginable, space is not empty at all? Scientists have long pondered what happens when you zoom in, far beyond what any microscope can see. Imagine you are flying high above the ocean in an aeroplane. From your window, the surface of the water looks perfectly flat and smooth, like a sheet of blue glass. But if you were to descend, getting closer and closer to the water, you would see waves, then smaller ripples, and finally the chaotic bubbling and frothing of the water's surface. This is what many physicists believe space itself is like. At the Planck length, the smooth fabric of space-time would dissolve into a roiling, bubbling, chaotic foam. Now, let's introduce another incredible idea from the world of physics, the wormhole. You have probably heard of them in movies and books as cosmic shortcuts. Imagine you are an ant living on a giant, flat sheet of paper. But what if someone bent the paper and poked a pencil through both layers? You could simply crawl through the hole, taking a massive shortcut. This is the basic concept behind a wormhole, first theorized by physicists like Albert Einstein and Nathan Rosen. They are a perfectly valid mathematical solution to Einstein's equations. We have journeyed into two of the strangest realms in modern physics. On one hand, we have the quantum foam. On the other hand, we have the wormhole. But what if they are not separate at all? The same violent energy fluctuations that cause space-time to bubble and boil could, in theory, also be enough to momentarily tear open tiny microscopic wormholes. So, what does the universe really look like at its most fundamental level? The best metaphor might be a block of Swiss cheese. From a distance it looks solid, but up close it's riddled with holes. The universe at this deepest level would have a spongy, interconnected structure. It would be a cosmic labyrinth of microscopic passages. This leads to an even more mind-bending idea called the ER=EPR conjecture. It suggests that every pair of entangled particles is actually connected by a tiny microscopic wormhole. The cosmos would be woven together by an impossibly vast and intricate network of these quantum tunnels. The fabric of space-time itself would be built from these connections. The existence of a universe riddled with microscopic wormholes would have staggering implications. A particle on Earth and a particle in the Andromeda galaxy could be next-door neighbors, connected by one of these tiny tunnels. This web of wormholes could be the key to solving physics' deepest mysteries, like how information escapes from a black hole through the quantum foam. Einstein taught us that nothing can travel faster than light through space. This cosmic speed limit seems to be an absolute barrier, but a wormhole changes the game entirely. A wormhole does not break the cosmic speed limit, it sidesteps it. It offers a way to cheat. If we could ever learn to manipulate them, to grab one of these fleeting tunnels and somehow stabilize and enlarge it, the possibilities are beyond imagination. The implications stretch even further. What if the wormholes in the quantum foam do not just connect distant points within our own universe? What if some of them connect to other universes? Our universe could be in constant microscopic contact with others. Could information be passing through them? Could the fundamental properties of our universe be influenced by whispers from other realities? The quantum foam is a place of unimaginable energy, constantly being borrowed from the vacuum. What if the wormholes provide a key to tap into this vast hidden reservoir of power? If we could ever learn to collect and stabilize a vast number of these tiny tunnels, we might be able to harvest this flow. We would be drawing power from the very fabric of reality itself. If wormholes in the quantum foam are real, it would mean that the map of the universe we have been using is completely wrong. The real map would be infinitely more complex, where every location is secretly touching every other location. The particles in your body could be linked to particles in a star being born in a distant nebula. We are not separate from the cosmos. We are woven into it in the most intimate way imaginable. We have journeyed to the very frontiers of human understanding. For now, this remains a world of theory, but the quest to find answers is already underway around the world. We stand today at the edge of a vast, unknown continent of knowledge. The ideas of quantum foam and microscopic wormholes are like the first hazy outlines of that continent seen from a ship at sea. So we end where we began, looking up at the night sky. But perhaps we see it a little differently now. The stars no longer seem so impossibly distant and isolated. We can now imagine that hidden beneath that smooth, dark canvas lies a universe of breathtaking complexity. A universe that is alive with frantic, bubbling energy, where every point is secretly connected through an invisible network of tiny, shimmering tunnels. This journey is about more than just physics. It is about our place in the cosmos. We are part of an intricate, dynamic, and unified whole. The universe is not just our home, it is a part of us and we are a part of it. The future of this exploration is unwritten. The young minds who will make the next great breakthroughs may not even be born yet. The greatest discoveries are still ahead of us. The possibility of quantum foam and microscopic wormholes tells us that reality is likely far stranger, more magical, and more mysterious than we can currently comprehend. And that is perhaps the most exciting thought of all. The next great journey is not necessarily to the stars, but into the very nature of space and time itself. The secrets are all around us, waiting to be found.